Hey physics people, welcome back to another dynamics physics problem, this one on gravitational force. What is the weight of a 67 kilogram astronaut A on Earth, B on the Moon where g is 1.7 meters per second squared, C on Mars where g is 3.7 meters per second squared, and D in outer space traveling with constant velocity? Okay, so a couple of concepts covered in this problem. Weight is the force of gravity. So whenever you see the word weight, always know that you're looking for a vector. This is Fg. Okay? Why? Because the force of gravity is dependent on the acceleration due to gravity, g. And depending on what mass you are close to or what it's relative to, usually it's relative to Earth. Okay, if you're dealing with a smaller object such as the Moon or Mars, the acceleration due to gravity decreases. If you were dealing with Jupiter, on the other hand, this g would be much, much higher than that of Earth, which is currently 9.8 meters per second squared. Okay, so for this problem, we are going to be looking for the weight of the astronaut on different planets. Now, your weight does change depending on the mass of the object, but what doesn't change is your mass, okay? And that's the constant in these problems. So the astronaut's weight on Earth, so W Earth, is equal to Fg Earth. I'm just going to put a little e there for Earth. The force of gravity formula is mass times g, and we're using g Earth. Again, mass is a constant, so it needs no subscript. Okay, mass is 67 kilograms. Acceleration due to gravity is 9.8 meters per second squared. And when you take the product of those two and express it in scientific notation, you will get 6.6 times 10 to the 2 newtons. So that is the person's weight on Earth. And you simply need to follow the same strategy for the next few parts. Okay, it's simply meant as a repetitive exercise to really keep that in your mind. Okay, so on the Moon, the weight of the person on the Moon is equal to Fg subscript m, I'll put mo for Moon, which is equal to the mass of the person times the gravitational acceleration on the Moon. So 67 kilograms times 1.7 meters per second squared. And when you take that in your calculator, you'll get 1.1 times 10 to the 2 newtons. Okay, hopefully so far so good. Now Mars is a bit more massive than the Moon, so we would expect a larger value here. So the weight on Mars is Fg ma, okay, for Mars, which is equal to the product of the mass and acceleration due to gravity on Mars. So 67 kilograms times 3.7 meters per second squared, and when you calculate that, you are going to get 2.5 times 10 to the 2 newtons. And finally, for part D. Now, part D is a little bit different, right? We're not given an acceleration due to gravity, but instead we're told in outer space traveling with constant velocity. So that word, constant velocity, those two words, very important. Whenever you see that, constant velocity means the velocity is not changing. In other words, there can be no acceleration. And if there's no acceleration, that means g is 0, because g is, after all, the acceleration due to gravity, correct? Okay, so g equals 0, therefore your weight, and therefore your Fg is equal to 0 newtons. Okay, so that's it for this video, guys. It was relatively short. I hope you enjoyed it. If you did, be sure to click that like button and subscribe to this channel so you never miss a video from me. Thank you guys, and enjoy the rest of your day.